Alright, right now we're going to be talking about the real number system. Okay. Real number system are the numbers that we pretty much deal with every day. Okay, they're what we use all the time. Every number you've ever dealt with has been a real number. I know some of you are probably wondering, why we call them the real numbers. Well, that's because there are such things as imaginary numbers. Those are stuff that we'll deal with when we get to Algebra 2. So right now, we're going to make basically a big Venn diagram. And so overall, we've got the real numbers. That's everything. But then we've got two major subgroups. Those subgroups are the rational numbers and the irrational numbers. Okay. Now, inside the irrational numbers is nothing else. If it's irrational, then the only other thing it is real. Okay, that's the only other thing it can be. But if it's rational, then it can be several other things. Because inside our rational numbers, we also have integers. Okay, inside our integers, we've got our whole numbers. And inside our whole numbers, we've got our natural numbers. Now, as far as what those are, that's down here. Okay. Now, the real numbers are, like I said, everything we've ever dealt with. It's all the rational and irrational numbers together. Okay, it's one big set of numbers. Now, it does have a special symbol. It's a funny looking R. However, when you're writing it out, you can just put a normal capital R. Okay, you don't have to try to draw the fancy looking R. I'm not going to be very picky about that. Okay, irrational numbers. Those are numbers that can only be written as decimals. They can't be written as fractions at all, and when they're written as a decimal, they don't repeat, and they go on forever. Okay, so it's 0.31759238894 etc., etc., etc. Okay, one of the most famous irrational numbers is pi. Okay, everybody knows pi. Everybody knows it's irrational. Despite one of my students last year telling me the most famous irrational number was money. Okay, for irrational numbers, its symbol is just a capital I. Nothing funny looking about it. Now, for rational numbers, these are things that can be expressed as a fraction. So if it can be written as a fraction, it's rational. Now, if it's a decimal that ends, it's rational, because that can be written as a fraction. Repeating decimals can also be written as a fraction. So, they're rational. Okay, 0.333 on forever. That's 1/3. It can be written as a fraction. Excuse me, and so it's rational. 0.7. It's repeating. That's 7/9. It's rational. Okay. Now, the symbol for rational numbers doesn't really make a whole lot of sense, but since R was already taken, we use Q. Again, it's kind of a funny looking thing with the loops around the outside and everything, but a capital Q is fine. You don't have to draw this exact figure. Now, integers, you've been dealing with these for a few years now. These are our positive and negative numbers. no decimals, no fractions, just our positive and negative whole numbers. So -2, -3, -4, -5, positive 1, 2, 3, 4, 5, and 0, all of those numbers. Okay. Again, I was already taken for the symbol, so we use a different letter. We use Z. Again, you don't have to draw it like that. You can just use a capital Z. It's no big deal. Just be aware that you may see them like this. Now, the whole numbers, those are just sorry, not just positive numbers. Those are the non-negative numbers. 0 is included here, and since 0 is not positive or negative, they're the non-negative numbers. So it's 0, 1, 2, 3, 4, all the way to infinity. Okay. Now the symbol here is nice and simple. It's just a W. Okay. Now, for the natural numbers, sometimes called the counting numbers, that's 1, 2, 3, 4 on to infinity. All we did is drop the 0. And the symbol there is a funny looking capital N. But again, just a normal capital N is fine. Now, the reason the natural numbers start with 1 is basically because when we start counting, we don't go 0, 1, 2, 3, 4, unless you're trying to be funny or just trying to be, annoying. You normally start counting things 1, 2, 3, 4. You never say 0, so it's natural. It's counting. Now, you may want to pause here and try these examples. Okay. Now, for these, what you have to do is decide which categories each of these belong in. So, square root is 16. Well, the square root of 16 is 4. So that's a real number. 4 is rational. Since it's rational, it can't be irrational. 4 is an integer. It's also a whole number. And it's a counting number. So it's everything but irrational. Now, 9/7. Well, that's a real number. It's written as a fraction, so it's definitely rational. So it can't be irrational. It's a fraction, not a whole number, so it can't be an integer. And since it can't be an integer, then it can't be a whole number or a natural number. So it's just real and rational. Now, -7. Well, that's real. It's rational, because again, a whole number can be written as a fraction just by putting it over 1. So since it is rational, it can't be irrational. It's negative, so that makes it an integer. But since it is negative, it can't be a whole number, since whole numbers are only non-negatives. 6. Well, that's real. It's rational because we could put it over 1. Since it's rational, it's not irrational. It's an integer. It's a positive integer, so it's whole. It's not 0, so it's natural. -8 over -2. Well, that's written as a fraction, so it's real and rational. Can't be irrational. -8 divided by -2 is +4. +4 is an integer. It's also a whole number, and it's a natural number. Now, the square root of 7. It's real, but the square root of 7 doesn't work out nicely And it's not a nice, simple, 2 times 2, 3 times 3 thing. And when you put it in a calculator, what you get is 2.645751311 on da 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 on and on forever, and there's no repeating pattern there. So it's not going to be rational, it's going to be irrational. And like we said before, if it's irrational, it's nothing else. And on the last one, square root of negative 9. This is a trick question, because the answer is none of them. It's not real, it's not rational, irrational, an integer, a whole number, or a natural number, because you can't take the square root of a negative number. If the negative was on the outside, we could, but on the inside, we can't. Because in order to take the square root of a number, it has to be the same number times itself. But in order to get a negative 9, we'd have to do positive 3 times negative 3. Well, that's not 3 times 3, or negative 3 times negative 3. And so the answer to this one is none of them. Okay. If you've got any questions, make sure to post them, and I'll see you in class.